I'm going to put this next to you. But I won't sit next to you, don't worry. Just the computer. All right, so I'm going to go over this together. Everyone take the quiz on Friday? Yeah? Okay. All right, so this just says state the postulate or theorem that can be used to prove. Right, so if I'm looking at something like number 1, looking at it right away, hopefully we remember that we can mark MO with congruent to MO, right? And that reflects a property. So I would be able to prove those two triangles congruent by that angle, side, angle. For number 2, for number 2, the only thing that we can mark right now are these vertical angles. Okay, if I mark that vertical angle, I would have an angle side, side, and angle side, side. So we can't use it. That's not one of our triangle congruency theorems, right? ASS is a bad word. If I said SSA, it's just that bad word backwards. So this would be not enough information. And again, the reason why is because we cannot use ASS or SSA to prove triangle congruence, okay? They don't work. Number 3, I have these two sides marked. These little black triangles mean that those two lines are parallel, right? So I like to extend my parallel lines and then look for my transversals. If I use JN as my line, I have this angle KLJ and this angle MNL. Those would be corresponding. They're in the same corners. So I can mark them. And then I would use side, angle, side as my triangle congruence. And this is kind of what you guys did your quiz on Friday. Any questions with that? Everyone's okay with this? Yeah? All right. So today we're moving on. Our essential question for today is what is the HL theorem? If you look on that sheet that I gave you guys, that proof reference sheet, right, it goes over the 4 that we've already learned: side, 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 angle, angle, and angle, angle, side. Do you need one of these? And the last one right there is called HL. So looking at that sheet, it kind of gives it away. What do the triangles look like in that picture? Right triangle. And if you remember parts of a right triangle, your H is going to stand for your hypotenuse. That's that angle across from the right angle. And an L is going to stand for a leg. So I'll kind of go ahead and I'll explain that to you guys. So this is just another way that we can prove triangle congruence, right? So now we are going to have 5 different ways. If all 3 sides are marked, we can use that side, side, side. Okay? Side, angle, angle, side, angle, and now we're learning this HL. This one says that if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. Okay, it's really important. 2 things. What is a hypotenuse? The hypotenuse is always across from that right angle. It's the largest side of a right triangle. Okay, so that has to be marked. That side across from that right triangle has to be marked. So in this picture, BC would have to be congruent to EF. So those are the hypotenuses. And one of the legs. So either BC and ED or AC and DF. So I would have to say BA is equal to ED. Then I can say that triangle ABC is congruent to that triangle DEF. Okay, so it's just the hypotenuse and one leg in opposite triangles. So this one's a little bit easier because all I need to do is mark 2 things, but it has to be a right triangle. It either has to be in the given that's a right triangle, or maybe it says the 2 lines are perpendicular and there's a right angle. We have to know that there's a right triangle now. So to use the HL theorem, the triangles must meet these 3 conditions. Okay, the first condition, it has to be 2 right triangles. If it doesn't say there's 2 right triangles, you can't use HL. You would have to resort to one of the first 4 that we learned. Okay, the triangles have congruent hypotenuses. This is the side that's across from that right angle, and there has to be 1 pair of congruent legs. So, looking looking at this, and this is where I mean, like in the given, it will say they're a right triangle. So in this proof that we're doing, it says that LPM and triangle MNP are right triangles. So I can go ahead and I can mark these as right triangles. Okay, easily see where my right angle is. Then I would say that ML is congruent to MN. I would mark this. What else can I mark in that picture? Go ahead.
The MP is equal to MP.
Yep, good. Why?
Because from the same line, it's like they're reflected.
Perfect. That's what reflects the property, right? It's a shared side. They both have that MP, so MP is congruent to MP. Now I can use my HL. I have a right triangle. The sides opposite of the right triangle, my hypotenuse, and one leg. So I'm going to use HL to prove that. Then we're going to go back right into writing proofs. First part, that line is given, so the reason would be given. The second part, that's given, that's why I marked it. That third part, MP is congruent to MP. I could say that because of the reflexive property. And then that last part, those two triangles are congruent because of HL. And that's it. So we're just learning one more way to prove this. I'm going to do another one. And then we'll do some practice. All right, so here's a whole blank proof this time. First thing we're going to do is we're going to read the given. This one says that triangle WVX and triangle YZX are right triangles. So WVX and Y are my right angles. It says that WV is congruent to YZ. So I would mark that. And then it says that X is the midpoint of WY. So what does that mean? If X is in the middle of WY, what's congruent? What should I mark in this picture? If X is the midpoint of WY, what should I be marking? Go ahead.
WX and XY.
Good. I was marking WX and XY. I have two right triangles, right? My hypotenuse is congruent, and then one leg, so I can go ahead and I can use HL. I would plug everything in. I would write out triangle WVX and triangle YZX are right triangle. That's given. I would write WV is congruent to YZ. That is given. X is the midpoint of WY. That's given. The only really thing that we wrote down or marked ourselves were that WX is congruent to XY, and that's this definition of midpoint. And I can say that those two triangles are congruent because of HL. Right, so all we're really doing today is I'm teaching you one more way to prove triangle congruence. All right. Do one more, and then we'll be done. Let's do some practice. So this says, are the two triangles congruent? If so, write the congruency statement. Right, so I would look at this. They're both marked right triangles. The hypotenuse is congruent. This is 6 and this is 6, so one of the legs are congruent. So I would say yes. Right, and then I could write a congruency statement. If I wrote a congruency statement over here, it would say triangle ABC is congruent to triangle. If I call this ABC, I went from the blank side to the 6. How would I have to name this triangle? Perfect, DEF. Letter B, if this is 90, what's this? 90, why? They're vertical angles, right? So I can identify these both as right triangles because if one is a 90-degree angle, the opposite side would be 90. So now they're both right angles. Across from their right angle is marked the same, so the hypotenuses are equal and one leg is equal. So I'm going to name this triangle MLP. If I went from ML to P, so the 1 to 2, what would I have to name this triangle? M what? I just couldn't hear you.
Wait, M-O-N, right?
M-O-N, yep, so you kind of just follow the march, right? It went from 1 to 2, it went from 1 to 2, so this would be M-O-N. All right, so what you guys are gonna do today is you're gonna do a practice in class, and we're gonna go over some of it, and then you guys have an exit ticket as a Google form.